Hello everyone, welcome to this video. In this video we will be studying about dihedral groups and about its Cayley table. Now you are quite unfamiliar with these two terms, dihedral groups and Cayley table. So we'll be answering all these questions in this video. So in the previous video you saw for a given square we have 8 operations which are defined in this manner, correct? And if we take all of these operations together and make some set which contains all these operations, then if we take the operation of function composition operator, what is the function composition operator? You remember when you compose the function f with the function g, then the ranges should be the same, and this is the composition operator, right? So in this case we are taking the same operator and together taking all these elements and this operator here, we are creating a mathematical system which is known as a dihedral group, and it has a order 4. Now what is this dihedral, what is this group, and what is the order? We'll be looking at it later on, right? I'll be explaining all the terms. And this particular mathematical system which we are naming by dihedral group of order 8, it is represented by the symbol D4. D for dihedral and 4 for square, right? Because square has 4 sides, correct? So now what is this order here? And what is this group and what is this dihedral? Group is basically it is consisting of a set which contains some elements. It could be anything. We'll be telling when this set together with this operation would form a group. We'll be discussing it later on, right? That is a group. And then what is the order of that group? So let me define. The order of a group is the number of elements it contains. So in this case this set contains 8 elements, so that means the order of this particular group would be 8 because it has 8 motions. Now in order to understand what are these groups, we are taking the example of this dihedral group. So for this dihedral group, what we are doing, we are just constructing all the symmetries of square, then we are constructing this group, and then we are seeing what all properties does this group satisfy in detail. And then using this example here, we will be studying in general what all are the properties that a group satisfy, and then we will be giving a formal definition for a group, right? So to understand the calculations, what we have to do, we first of all have to draw a table. Now what is this table? Now this table will which we call either by the operation table or by the Cayley table, that will represent all the calculations that we will be making by, for example, in this case of dihedral group, by these 8 elements, right? In this example 8 elements plus one operation which is this function composition, right? By function composition. So we'll be looking and this thing would be there whenever we have finite number of elements present in the given group. So this table could only be performed whenever we have finite number of elements. So now you must be thinking, what is this Cayley table and how we may define it. Let's understand what is this Cayley table. So this table describes the structure of a group. How? Because it contains all the calculations, right? And this is only defined whenever we have finite number of elements which are present in the group. And this table, what it does, it arrange all the elements first of all in first row and in first column, and rest of the objects or elements, they are obtained by applying the assigned operation, which in our case it is what? It is the function composition on the given elements. Now you will be not getting it at once, what is this Cayley table. So let me show you this. This is the Cayley table. Now what you are doing, you are writing all the 8 elements first of all in this given row, right? Row wise. And then you are writing all these 8 elements column wise in the first column. Now what you will do, you will just for this entry here, what you will do, you will compose the first element taken from here R0 with the second element taken from here. R0, and you will find out what is the answer. Similarly, for the second element here, what you will do, you will take the first element here, R90, and then compose it with the second element here, because this corresponds to this column and this row, right? So it is R0. So you will find out the answer. Similarly, if you wanted to calculate what is this entry here, for that this is the element here. So first of all you will write R180, then you will compose it with this particular element here, which is R270, and you, after calculation, you will find out what is the element. Whatever is the element, you will substitute it here, and in this way you will fill whole of this table. So this table will represent all the calculations that is made by the group using these 8 elements and the operation of function composition, correct? So this is the Cayley table. Now this table was named after an English mathematician which is named as Arthur Cayley, and he introduced this Cayley table, the concept of Cayley table, in the year 1954, correct? So for D4, as I have told you, we will take all these 8 operations here. These are basically the elements of the group, and the operation here that we will be taking is function composition. So keeping this mind, we have to fill in this table. Now how we, as I have told you, to obtain this element here, we have to multiply R90 with R80. So how we are going to calculate this this element here? Let's see and proceed. For that we will proceed further. So here, suppose we wanted to fill this element H R90. Now what is this? H is here and R90 is here. So basically we wanted to calculate for this H and R90 what is the value. So let's see how we can calculate it. So you see, the operation here is function composition. So that means first of all we will be solving for this one. So basically we will be taking the operation R90. So this was the given initial matrix. For this initial square here, not matrix, for this given initial square, we have to first of all apply the operation of R90. So after applying it, we have this matrix. So I have written it here. After that, we have to apply the operation of H onto it. Now what is H? What does H do? H flips the given square, right? And it flips it in such a way about a horizontal axis like this. So this color would come here and this color would come there, go there. So you have red and pink in this order, similarly blue and green in this particular order. And let's identify what is this square here. This particular square here, does it match with any of the 8 squares which are given here in this manner? So let's see whether the colors match here for anyone. So here in this particular case, this is nothing but the D matrix. You see, we have a green here, we have a red here, we have a pink here, we have a blue here, and the same thing happens here: blue here, pink here, red here, and green here. So this is what? This is the operation D. So basically when you compose this H with R90, you are getting a D. So we will write it write the D here in this particular case, right? Let's now check for another entry here. Say we are checking for D and V. Now what is DV? So you see, we have D here and V here. So that means we go here like this, and V, for V we go like this. For we are looking for this entry D composed with V. What is this? So let's have a look. What is this? So first of all, we'll be applying the operation V onto the given square. So when you apply V onto the given square, this one, you will be getting this as the final square, right? So I am just writing it down here. So it is this one: blue, green, pink and red. Now we have to apply the operation of D onto it. So when you apply D onto it, so what we have to do, we have to flip it across the main diagonal. So for that, we will first be drawing this main diagonal like this, and then we will flip it across the main diagonal. So that means this pink color would go to the place of green, and this green one would go in the place of pink, right? And blue and red would be kept as such. So you have this as the result. And if you match this, this is the same as the as the square which you obtain after applying the operation of R90. So you have a blue here, you have a pink here, red here, and green here, and the same thing happens here. So what is this? This is R90. So you have the final answer as R90, which you can write here as R90. Similarly, let's look at another operation, which is H into H. So basically we are performing this operation. H is here and another H is here. So we are looking for some element which is placed here like this. For this particular entry here, we have to perform H into H. So what is this thing? So basically we have to first perform this H here. So when you perform this H here onto the given square, we are flipping it across the horizontal line. So we are obtaining this square. So I am writing it down here. For this particular square, when you again apply H onto it, so basically you have to again flip it. So when you again flip it like this, this red will go here, green will go there. So that means you will have this this square, and this square is what? It is the given initial square. So this square is what? This is the square which is obtained after applying the operation of R0. So you could write this thing as R0. So the answer to this one is R0, which you can write this. So I insist you to calculate all the entries here of this table and write it down and complete this table in this manner. Once you have completed it, just play the video and complete the rest of the content, right? So I hope you are pausing it, right? Okay, so let's see what table have you obtained after performing all the calculations here. Does your table match with my table here? So my table looks like this. So you could pause this video here and match this table with the table that you have obtained after performing different calculations. So it should match there. If that is so, you have obtained the Cayley table for the given dihedral group of order 8, right? And that is it for this video. Thank you for watching.